All right, this is 2.4, the last lesson for Unit 2 on altitudes. Um, so this is our last warm-up. So give it a pause, and then we'll go over it together. So we want to find the slope of a line that is perpendicular to the line that contains points A and B. That means first we need to find the slope of this line. So remember, if we want to find the slope of this line, we use our slope formula. Whoop. So we're going to do y1, -9, minus y2, -9, minus y1, +6, over x2, which is +3, minus x1, -2. So -9 minus 6 is going to be -15. And then -3 minus -2 is the same as plus +2. It's going to be +5. And -15 divided by 5 gives us -3. So we want to find the slope of a line that's perpendicular to the line where the slope is -3. So we have to find the negative reciprocal to -3. So the answer to this, the negative reciprocal for -3 is +1/3. So that's our answer to our warm-up. So our objective for this one is we're going to apply the rules of perpendicular lines and distance formula to find the distances between points and lines. So the distance from a point to a line is that when a point is not on a line, the distance from the point to the line is the length of the segment that contains the point and is perpendicular to the line. That sounds really complicated, but what it really means is that when we're finding the distance between a point to a line, the shortest distance from a point to a line is a straight line. It sounds complicated, but it's not. Hang on just a second. Where'd it go? Okay, so let's look at our exercises on our paper. We want to construct some segments that represent distances from our points to our lines. So in this one, we're constructing some segments that represent the distances from C to AB. So we want a straight line from C to AB. Straight line there. That's it. Straight line from C straight down to AB, and that's it. That's our distance. It sounds like it's going to be complicated, but it's not. Here, we want D to AB. So to make a straight line from D to AB, the first thing we've got to do is we've got to extend AB, and then we can make our straight line. We've got to make sure that that is a perpendicular line. That is how we know it is the shortest distance possible, is we are making a perpendicular line. So from T to RS, we got to make sure that from T, we're drawing a line perpendicular to RS. So we extend RS just a little bit. We can make a perpendicular line there. And then from S to PQ, We got our perpendicular line. And then our last couple of problems, we're finding our distance between the lines. You do not have to graph your lines, but just as a visual example, we're talking about y equals -2 and y equals 3 to find the distance between these lines. Y equals -2 is a horizontal line here. Y equals 3 is a horizontal line here. So the distance between these lines is 5. We're talking about two horizontal lines here. So at any point, the distance between these lines is 5. Talking about x equals -9 and x equals 5. These are two vertical lines. So at any point, the distance between those lines is 14. And point 3, -2, and y equals -1. This is just one point. So this one's even easier to visualize because the distance between this point and this line is just 3. And that's it. That's all the notes here. You've got one page of homework, and that's it for this unit. We're going to have review on Tuesday, December 17th, and this notes packet and homework packet are due December 18th. So make sure to email me if you have any questions, and see you next time.